light gray it is. And as you can see, the plug is longer. Anytime you have new style and old style, the new style will work on the old style machines, but the old style cord will not work on the new style machines. So I'm going to plug this in and make sure that power is off. Looks good. No problem so far. Going to hit the power button. This individual has an LED light, not a problem. The original one was an incandescent 15 watt. Here's where you get the display, battery, so on. That means because there's no batteries in it. That's why it's saying that. If the batteries were in it and they were dead, when you turn the machine on, you would get this prompt. Hopefully that would be enough for you to say, I might need batteries. Unfortunately, in most cases, it didn't help. And the batteries leaked and the circuit board was destroyed, and there we are. Okay, so it lights up. Good. Another area of wear on these machines, common wear, is the motor brushes. It's an electric motor. Here is an example of a newer style motor. Outstanding motors. Have no problem with them, with the exception of maintenance. People don't have machines maintained properly, and therefore the bearings and the motors go bad because they run them 30 years without oil. So the other problem with motor brushes is The other problem with motors is motor brushes. All electric motors use brushes, and I'll show you. This is the motor brush from this machine. This is an original equipment part. That was what was installed when it was made. This is woefully inadequate for this machine. These wore down very quickly. It's a 12.5 millimeter brush, 4x4, 4 millimeters wide, 4 millimeters square. The Germans finally, after seeing this, improved this brush, and with the introduction of the model 1475, actually earlier in the model 1473, this brush was installed. As you can see, it's much bigger, much longer. This is a 5x5 brush, much longer, and it uses a different spring assist. The problem that arose with these springs, with this brush, okay, what I've done is I grabbed a used armature out of a motor, similar to this, came out of a 1400 series machine. This is the commutator, this round part here. This is where the brushes seat. There's two brushes, one on each side. It goes something like this. When this brush wears down, this black part here will wear down. It'll wear like lead in a lead pencil. This is turning and this is rubbing on this. And after a while, this keeps continuing to wear down, wear down. Eventually, the only thing left is this spring. Now, this spring, being copper, still makes a contact. And what that does is allow this motor to still run with no brush, but rubbing the metal spring against the commutator. That'll start to cut a groove in this material here. Now you're going to get arcing, and you'll get an ozone smell. So that means you need work here, in this part and in the brush. So what I do here is I turn the armature down so this is absolutely trued up. It's round, and this is now ready to accept either brush, and it'll make a nice contact. which is what's going to happen to this machine. This is still good, but it needs to be machined. This has to be cut on a lathe so that it's trued up. That's what we do here. That's the proper way of servicing the motor, the drive motor. The drive motor on these machines is a high voltage motor. It's an AC motor. AC meaning alternating current. Most modern machines today use DC motors, direct current. This machine used an AC motor. Your power comes in from the wall to the motor. The motor draws its high voltage power from this. This is just the signal wire for your control. This cord passes the high voltage down to your main circuit board. From that point, there's a transformer that breaks it down into other voltages for other purposes. So, you have an AC drive motor, and you also have an AC light. Everything else is AC, but it's not high voltage, it's lower voltages. It can be 32 volts, some part of the circuit has a 5 volt, and we won't go into all of that detail. Another part here, let's go back to this cover. This cover's got a couple of things. This is your bobbin winder thread guide. It's just pressed in there, and this will pop off easily. If you get angry at the machine and you've got your spool of thread on here, I'm going to put this on here, and if you were to get angry and this catches and pulls your clip out, it went somewhere. Okay. This guide will come out of the cover, take off, and you'll probably not find it. These are no longer available. Without it, you don't have a guide to go from your spool pin over to your winder. So, don't lose this piece. So now let's review the don'ts on this cover alone. Don't mess with this, and don't lose this part. Now, for unreeling discs, or spool caps are called. Okay, I'm going to talk a little bit about the spool caps. This seems to be a mystery to a lot of folks. Here we have 3 sizes that came with the machine. And the purpose of that is, when you buy a spool of thread, you're going to have the end, and oftentimes on some spools you'll find that the thread is caught into a little nick in the plastic, and that's to hold the end of the thread, like so. What I do with these kind of spools with the paper label, I peel the paper off and I put the little nick that held the thread to the back. Now you always are going to use a spool cap that's larger than the spool. The purpose of these is not only to hold the spool onto the pin, but also to protect the edge of the spool, so you have a nice smooth surface here. So when the thread comes off the spool, it doesn't catch on anything. That's why the spool cap must be larger than the spool that you're using. That's why they give you the 3 sizes. Whatever size spool you have to use a cap that's larger. Now, here's another style. This is a Mettler product. This has a little catch on the end. Very nice design. And it's smooth. So even if you don't use a cap on these, the thread won't catch on anything. But what it does is it wants to walk around on the pin. So in this case, I'm going to use the larger one, which is this one. Now I could use this one, it'll still work. But this is a more ideal size for this spool. Now, there are folks that want to use mini kings like this. I'm not crazy about this spool on here, but it can be used. On this one, you don't need to use a larger one because the thread is actually tapered, so it's not going to catch on anything. On this spool, you can use this small one and just set it in the middle. Now this thread will come off easily. Won't snag. So there are many kinds of spools on the market. But you have to make sure when you're using these machines with lay down spool pins is that the thread as it comes off of the spool doesn't get pinched down in between the spool and the cover or whatever the obstruction might be on the spool. Now on this one, no problem. You can lay this one down, no problem. You have these spools. This is a dual duty product, same as this was, different spool. This one, bigger. Here's a case where it's smaller. Now here, I would say this is okay because this surface is pretty smooth, so it's not going to get caught anything. But theoretically, you should use this one. This is bigger. Now you won't have any problem. And the other thing is, oftentimes when you're sewing and your thread breaks, you're looking at the needle. You're looking here. The cause of the thread breakage can be anywhere from the spool all the way down through the thread path to the needle. It's always going to break at the needle. And you're always going to be looking at the needle, not up here, not over here. You're going to be looking here when it breaks. So, the reason for thread breakage can be a lot of things. And it's not that easy to pin it down. You have to kind of know what to look for. These brushes. So, another thing we see people like to do a lot. A lot of times people will want to wind their bobbin with the thread threaded through the needle. Get a lot of people say that it says that they can do that in the book. And if it does say it, it also will outline how to do it. Personally, I would not do that. The reason is you're not saving much time. I'm going to show you how to thread this machine. Always have your presser foot up. There, threaded. Now, how much time are you going to save by pulling this thread up here like this? Well, what's going to happen, like it's happened here, is start to hog a groove in here. We've seen them where they're up here and they go over. Now, this is all cut up. When you're pulling this thread through that at a high rate of speed, and you will be, as soon as it catches, you're going to mash down and go as fast as you can go. It's going to pull this thread through at a high rate of speed. It's going to start cutting slits in this plastic. So, you've ruined the plastic, and imagine what it's done to the thread. So, you now have half the amount of thread, because the rest of it is a ball of lint on the back of the plastic. So you didn't save any time, you ruined the plastic and you ruined the thread. And you saved no time.